Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing about the overflow problem of sigmoid. So what exactly is this problem? First we'll try to understand it and then we'll discuss its solution. Okay, so everyone must have heard about what sigmoid function is. So this is how the sigmoid graph looks. Sigmoid is used in logistic regression, and it is also used in binary classification in neural networks. Okay, so it is one of the activation function as per neural networks, and even in classical ML, it is used in logistic regression. Okay, so this is how the graph of sigmoid looks, and here we can see that when the when the value is positive, let's say from 0 to infinity, the graph would always be squeezed between zero point 0.5 to 1. So whatever is the value from 0 to infinity, the values of sigmoid function will be from 0.5 to 1, and from minus infinity to 0, the value would be between 0 and zero point 0.5. So the range of sigmoid is from 0 to 1, and the domain is from minus infinity to infinity. That is how sigmoid is defined. The formula for sigmoid is 1 upon 1 plus e to the power minus x. Okay. So there is one more formula. Uh, it just we take the reciprocal of e to the power minus x and push it above. So both those formulas look like, I'll show you. Tutorial point whiteboard. So the first formula is 1 upon 1 plus e to the power minus x. Okay, that is one formula. Now let's say if I convert this e to the power minus x as 1 upon 1 upon e to the power x, and then if I push this e to the power x, so the another way of writing the same formula can be e to the power x upon e to the e to the power x plus 1. Okay. Yeah, so just bear with this thing. I'm using a keypad here. Okay, so these are the two formulas of sigmoid. So what's the problem? Let's use this formula, and even the graphs also says that it's proper. Just send it any value between minus infinity to infinity, and it will give a proper appropriate value squeeze between 0 and 1. So let's see what exactly happens if we try to do it. Okay, so before that, let's define sigmoid. Okay, so we can use any of this formula. So for implementation in the first function, you can see this formula. Okay, so it is 1 upon 1 plus e to the power minus x. Okay, now let's see how this formula gets executed. I give it value 0, so 0 should be 0.5, so it is 0.5. Then I gave it 2, 4, 10, 100 and 1000, so 2 should be somewhere here, so it is giving me 0.88. Then 4 should be somewhere here, so it is 0.98. Okay, and after 6 and onward it should be roughly 1. Okay, so it is giving me exact 1 at 100. Okay, at 10 also it is 0.9999 something. Okay, and at 1000 after 100 it's turning into 111. Okay, let's try to pass it negative values. Okay, 0, minus 2, minus 4, minus 100 and minus 1000. So up till here it was fine. 0.5 minus 2 is also minus 2 is somewhere here. Okay, so it is some value point close to 0.11. Okay, here something 11. Then minus 4 also somewhere close to 0, and finally after at minus 100 you're getting a value 0. But when you pass the value minus 1000 to it, it gives a error, overflow error. Okay, so why so? The function is working fine. As per the function, it should be a value given as 0. So why it is giving a overflow error? Now what happens is internally, whenever you might be using sigmoid let's say in sklearn or pytorch or tensorflow, and just imagine you are getting this error while passing any negative value as a data input, so it will become problematic. Okay, so we need to handle it, and we also need to understand why exactly are we getting an overflow error while passing a highly negative value, but we didn't got the error anything while passing a positive value. Okay, so let's first try to understand this overflow error in detail. Okay, so when I was passing minus 1000 here to sigmoid, okay, so here in this function, because it is minus x, to np dot exponential, a positive value of 1000 was going. Okay, and because of that very high value being passed to this np exponential function, it was throwing a overflow error. So we can see that when you pass a positive this same error, okay, when you pass 1000 value to np dot exp, here it is giving a overflow error. Okay, and it's telling that it is infinity. Okay, so so the thing is that it is giving a overflow error. So we understood that the overflow error is coming from this function, exponential function. Okay, so why is it happening that you are facing an overflow error here? Okay, so let's just see what the graph of e to the power x is. Okay, so this is how the graph of e to the power x and e to the power minus x looks like. Okay, so okay, so this is e to the power minus x and this is e to the power x. Now here, by passing a positive value to e to the power x, we were getting overflow error. So just observe this e to the power x. Okay, this meeting point value here is 1, where you put e to the power 0 and we get the value as 1. Okay, now when you pass a negative value to e to the power x, it is closing towards 0. Okay, it's fine, but when you try to pass a very positive value to e to the power x, as you can see, this graph is going upwards towards infinity. At 1000 itself, it was trying to reach infinity. Okay, now because of that, what happens is, because the value is very high, the floating the floating number limitation in numpy takes a hit. Every data type which is defined, it has a certain range, a certain limit. Because you are passing a very high value to the e to the power x, the result will be a very high value here. Okay, because it's a very high value here, the floating point value, the range of the floating point value takes a hit, and because of which it throws an error of overflow. Okay, that it is overflowing the floating point range defined in the numpy. Okay, so now how to fix it? Because this is a core, this is, I'll say, problem in uh, the way numpy is defined, right? In numpy you have lots of data structures. I won't say data structures, but different types which you can assign to variable, like int 32, int 64. The way similarly we have float 32, float 64, and lot many data types, lot many d types. Okay, now how to fix this? We are facing this issue because of the d type, because of the d type issues in numpy. So what we can do is, one of the way, so that you won't encounter this problem while passing a negative dataset value to, let's say, logistic regression or any algo which uses sigmoid, is you make a way out of it. Now how to make a way out of it? Okay, so one of the way I'll say is that we will be doing here two implementations of sigmoid. One implementation for positive values and one implementation for negative values. Okay, so these two formulas which you are seeing here, the first one is 1 upon 1 plus e to the power minus x, and the second one is e to the power x upon e to the power x plus 1. Okay, so these are the two implementations made here, right? And as you can see that now, whenever you pass any very high positive value to the sigmoid positive function, it doesn't throws a overflow error. But if you pass a very high negative value to the sigmoid underscore positive, it will give you an overflow error. So what we can do is we'll be passing negative values only to this sigmoid negative function, and as you can see that you are not getting any error here. So how it's handled internally is there will be a if loop there, and it will check whether the number is positive or not. If the number is positive, it will be passed to this version of sigmoid, and if it's a negative number, it will be passed to this version of sigmoid to make a way from this overflow error which we encountered because of the d-type limitations of numpy. Okay, yeah. So this is how it is actually handled for you in libraries of PyTorch, sklearn, and TensorFlow. So that's why we don't encounter this error. But the ones who have implemented the algos for you, they have handled it for you behind. So in PyTorch, TensorFlow, and sklearn libraries, you will be seeing two versions of sigmoid. So ever if you get a chance to go into the class implementations of the different algos, please go there and please see how the optimizer sigmoid is implemented in PyTorch, or how the logistic regression sigmoid function is implemented for sklearn. And there you will see two different versions of sigmoid handling this problem of overflow. Okay. So yeah, this was my attempt to explain you what exactly is the sigmoid overflow problem, and how it's solved. Okay. If you find it helpful, just give it a like, share it with your friends. Do check other videos and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.